here's another example. This is a pulley system question, which are quite common in physics. So we've got a block sitting on the table, this one over there. This is 2 kilogram mass and it's placed on the bench, and it's attached using a string to a 0.5 kilogram mass, which is hanging vertically over the side of the bench. So our first question is, if the bench is frictionless, so ignoring friction, calculate the acceleration of each mass and the tension force in the string. So let's just look at the two masses separately. We'll separate them and just look at the free body diagrams. With the first one, we have sitting on the table, so we've got a weight force acting downwards and a normal force acting upwards. These two are going to cancel each other out. We don't need to worry about these ones in this problem. And then we've got a tension force from the string pulling it along. This tension force is going to be given to us by m1a, the acceleration that is making it move. So this means that our acceleration equals tension over m1. So that's quite a useful thing to keep. Then in our other system, we've got the weight force acting downwards, m2g, and also the tension going upwards, okay, and that's going to be due to the acceleration. So let's go through and work out the weight force first of all. It's going to be m2g, which is equal to 0.5 times 9.8, which gives us 4.9 newtons. Now to find the acceleration of the system, we're going to use the force equals capital MA. Now I've defined capital MA for this question to be the total mass, so it's little m1 plus little m2. So this is the acceleration due to both of the masses, and the force is due to gravity, so this actually equals Fw. So this means that acceleration is going to be Fw over capital M, which equals 4.9 over 2.5. Let's put that up there. So that's 2 plus 0.5 kilograms. And this gives us an answer of 1.96 meters per second squared as our acceleration. Okay, so now all we need to do is go back up here to this formula to work out the tension. We know our acceleration, that's what's moving the first block along. So we can say that 1.96, actually we can just go to the top part of this equation, can't we? And say that, we can use this bit there, say that tension equals m1, which is 2, times acceleration, which is 1.96 meters per second squared, and we get an answer of 3.92 newtons. Okay, so that's given us all of part A. So it's the acceleration of each mass and the tension force in the string. So now for part B, if there is a friction force of 2 newtons acting backwards on the 2 kilogram mass, redo part A. So now we're actually going to consider this bit in there, and that is 2 newtons. So with our block, we actually have an extra force there, 2 newtons. Okay, so frictional force, Ff, equals 2 newtons. Now our net force, this is going to be 4.9, because we had 4.9 newtons from up here. So there's a force that was pulling the masses down towards the ground, minus the frictional force, because the frictional force is in the other directions, it's backwards. So we're going to subtract that and we get 2.9 newtons, and that's our net force, so the force that's left over, that's actually occurring. Okay, so now what we can do, we know that F equals ma, so the acceleration is going to change because we've got this frictional force. So acceleration is going to be F net over capital M, mass, which is going to be 1.16 meters per second squared, and that's the acceleration. So now we use that with our formula for tension, so therefore tension is going to be m1 times A, which equals 2 times 1.16, which equals 2.32 newtons. And that's our final answer. So to summarise, when you're doing tension problems like this, you need to calculate the total force and the total mass. So remember that the forces inside an object cancel. Acceleration equals total force divided by total mass. So that was like in our example with the F net. And then to find the tension, calculate the net force on one object. So you look at them separately.